All right. So basically, hello everyone. We are going to start with another lecture of advanced performance management. It's going to be a very short lecture because in this lecture we are going to deal with the basic concept of statistics, basic ideas of statistics, right? So what we are going to deal with, see, whenever you do a survey, whenever you take opinion about the average income levels, average expenditure, average feedback about any product or anything, you have to analyze those results in order to finally conclude something or to decide something, right? So for that conclusion, that decision, there are certain statistics method which we use to analyze the data. So for data analysis, the first thing which generally we use is the arithmetic mean, right? Arithmetic mean or the average value which we generally calculate, and we all know that as an average value. What is the average value? So let me try to calculate what is the average value, and then I will show you what is the problem with the average value, right? This is a very basic standard lecture, so maybe you guys are aware of such things. So if you are, then you can skip this video. Otherwise, you should have a basic idea of all these things. I know you guys are not supposed to calculate all these things in your exam, but still, you should know what are these things, right? So if you want to calculate the mean value or the average value, how can you do that? Mean value or the average value is the sum of all these figures, right? Is the sum of all these figures. I'm not deliberately calculating the average value and dividing it with, I mean, not directly calculating it, divided by 5, right? So there are 5 people whose income level has shown below, right? And the average value or the mean value of the income level is 229, right? Let me try to highlight this. Let me try to highlight it like this, right? So if someone says that, okay, fine, let's hide all these figures and let's concentrate on this value only. Okay. Suppose if I say that, okay, fine, you have to draw a strategy, you have to, launch a product which is going to deal with the income level of people. So what the result is actually suggesting is that all these 5 people are on average earning to 29,000. Let's suppose these figures are 1,000. So on average, these 5 people are earning to 29,000, right? So in that case, if you are launching a product which will cost around 50,000, that is still affordable by all, right? But the reality is not this. The practice, if you see the result, if you see the income level of these people, you can easily understand that there is an outlier. This 1,000 is an abnormal figure, right? Abnormal is called outlier in statistics, right? Right. So this 1,000 is an outlier figure. Outlier figure is means that this figure is actually disturbing the average value because not everyone is earning, not even 50,000 people are earning. So this mean is, we say that this mean is not a true representative of this whole data set, right? Let's suppose if I make it like 32, in that case, the mean value will straight drop to 35.4, which is to somehow can be a reasonable figure which is representing this whole population. So this 1,000 is actually disturbing this whole average value. So if there is an outlier, then this average figure can may not represent the true picture of the whole population. Population means, I mean, the whole data set, right? So what we can do here is that what is the solution of this? Solution is basically median value. Right? Median value actually represents what? Median value will represent the middle value of this whole population. So if you put all these figures in a sequence like 30, 30, uh, 40, 45, and 1,000, right? If you put all these figures in a sequence, then the middle value will represent the median, right? Now, what will be the benefit of this median? See, mean is representing the average value. Somehow if you see the highest and lowest figure and if you net it off, it will be the average value. Right? What is this median value representing? Let's suppose if this 1,000 is not 1,000, this 1,000, this 1 million is even 5,000. So your average value will go up. your average value will go up to 1029. Let's suppose if its inequality is so high that it's 10,000, your mean value will go 2029. But there will be no impact on your median, because median will still remain the same, because irrespective of the fact whether it's 1,000, 10,000, or 20,000, or 40,000, or 90,000, whatever this figure is, your 40 will remain in the middle, right? So median is a better representative of your result in case you have an outlier or you have one or two or three outliers, right? But in the absence of any outlier, median and mean value both are reliable, right? So that is the median, right? Is to provide the middle value, especially useful in a data set with an outlier or skewed distribution, right? So that is basically the fact, and it will not get any effect if there is an outlier. Skewed distribution, I'm not going to that discussion, because if there is an outlier, your mean value will go either on the right side or the left side, and the whole distribution diagram can affect it. So what is mode? The third figure, which is the third value, which is generally used in the statistics. Mode represents the most frequently repeated value in your data set, right? So in this case, the most repeated value is 30, right? So 30 is representing mode, right? Now, what is the benefit of using mode? Mode will tell you which figure is mostly present in your data, right? So that you can decide accordingly. Mean consider all values. Median consider just the middle value, but there are chances that there will be another. There can be some more figures like let's put me 30 here, and let's suppose I'm putting 42 here, right? So there are three figures which is representing 30, right? So if there are three figures which is representing 30, then that means that mostly people are earning 30,000 on average, right? So that's basically this thing. That's basically the concept of mode. So mode actually represents the most repeated value in your data set, so that you can take decisions accordingly. That okay, fine, if median is 40, but what is mode? Mode is 30. That means mostly people are earning 30,000 units or $30,000 in this particular case, right? Now here comes the last part. Last one is quite interesting. The standard deviation. You may find this standard deviation in your exams, which is a good. It's an interesting thing. Sorry, which is an interesting thing. So what is the standard deviation? Standard deviation basically represents the deviation from your mean value, the deviation from your average value, right? Let me try to simplify this with an example. Let's suppose there are two students, student 1 and student 2, right? Hope my voice is recording. Yeah. Hello. Yeah, it's recording. Actually, this is my fourth recording. Okay, so standard student 1 and student 2. So one student got 49 marks and the other student got 51 marks. So if you want to calculate its average figure, if you want to calculate the average of these two, sorry. Average of these two figures, you will get 50, right? And let's suppose if I'm saying that no, it's not 41 and 50, it's 10 and 90. Right? Still, you will get an average of 50. And if I change this data from 0 to 100, right? One student got 0 marks and the other student got 100 marks, still your average is 50, right? So there are two sets of information, set 1, set 2, and set 3, right? So set 3 is actually, there is a problem with set 3. If you want to take decisions on the basis of if your figure, if your results are set 1, student got 49 and 51, then you can take reasonable decision. But if you're saying that we want to take decision on basis of this 50, the last set 50, then that will be a deceiving figure, because one student is both the students are far away from your mean value. One got 0, another got 100, right? One is quite IQ level of one or intelligence level of one student is quite better than the average, and the other student is quite dumb. But that's basically the reason why we cannot trust this average value. So what we can do now is that, okay, fine, one more thing. If you want to calculate the deviation from mean, so the standard deviation is of the first set is quite low, is the lowest. And the standard deviation of the last set is highest, because that's representing the most variation, the highest variation from the mean, right? So how can we calculate the standard deviation? I'm just telling you the way to calculate it, but you are in exam, you are not supposed to calculate that. So the first step is to calculate the average value, that we already know. Let's make it 1000. Okay. So the first way is to calculate the average figure. The second step is to calculate the deviation from mean, but this is not the standard deviation. So what we are going to do, we are just trying to copy and paste it here. Sorry, let's see. Okay. So these are the mean values, and if you want to calculate the deviation from mean, so generally it's minus plus figures. So if you add all these figures, this in totality, the total will be 0. Right? And that's the reason why we won't stop here. We generally calculate its squared value, so that this negative impact can be, we can get rid of this negative impact. So this figure times 2 is, and this, right. So, and the next step is to sum all these figures, sum of all these deviations, right? Now this is not going to equals to 0. Right. So, and then what we have to do, we will calculate the variance. Variance is simply the sum of deviations divided by n minus 1. So 5 minus 1. I'm not going all right, so the variance is basically this figure. Now, what will be the standard deviation? The standard deviation is basically the square root of this figure. So that would be SQRT. SQRT of this figure, right? So standard deviation is 1.3. So if I keep this data to be 30, 32, 40, 45, which was the original data. So the standard deviation is going to be around 431, which is too high, right? You cannot take decision on such basis. But 431 means that your values have a deviation from mean around 431, which is obviously not the true representative, right? So, and if I reduce this 1000 to 100, the standard deviation will reduce to 29. If I reduce this 100 to 30, then my standard deviation will be 7.07, but it's still 40 and 45 are quite, is basically the deviation, a lot of deviation, right? So if I keep it 32, my deviation will be 4.3, it's reducing. If I keep this 30 as 30, right? In that case, the standard deviation is far low, because 4 figures are 30 and 1 figure is 32, right? But let's suppose if this 130 instead of 1 D income being 32, let's suppose it's around 1000, still your standard deviation will go quite up, right? So obviously you can understand that what the standard deviation means, and what one wrong value, one outlier can have an impact on the whole result and your interpretation and your conclusion, right? So that's basically the reason why we really need to care about such things, why not all the time arithmetic mean or the average gives us the correct interpretation. In this case, the average is 224, and there are four values where the income level is around 30,000. So this 224 is at all not presenting the true value of the population. Um, median is still better because median will be around, I think, 30. Median will be in this case around 30, and because if we put all these figures in a sequence, median will be still 30. Median is not getting affected by this. And if you see the mode is around 30 because four people are having income level of $30, 30,000. And standard deviation, if you keep this 1,000 in your results, then obviously your standard deviation is there's a lot of deviation. But if this is 32, your standard deviation will reduce, right? So that's basically the idea, just to give you a basic recap of what is the standard deviation, mean, median, mode, and how it can affect the results, and how and why we should be take care about we should take care of such figures. All right. So do watch this video, and we will do the question. We will, I mean, Sunday questions actually based on the standard deviation concept. So I just thought to give you a basic idea of this. All right. Then, so see you on Monday. Sorry, Sunday. Till then, take care. Allah Hafiz. Bye bye.